So in the last class, we were discussing about routing, right? We were discussing about routing and we have configured static routing on Palo Alto firewall. Today we are going to learn about dynamic routing. Okay. In terms of dynamic routing, we are going to learn about OSPF and BGP. How can we configure them on Palo Alto firewall? Okay. In static route, I told you about host specific static route, then network specific static route and default route. Okay. And default route. These are the different types of static routes that can be configured. Now let's move to dynamic routing. So I told you about dynamic routing. That dynamic routing is used to advertise and learn routing information between the routers with the help of routing protocols, right? To perform dynamic routing, we use different types of routing protocol. To perform dynamic routing on the firewall, we we to perform dynamic routing on the firewall, we use routing protocols. Okay. So that the devices can advertise and learn routing information between them. Okay. So that the devices can advertise and learn routing information between them. Okay. So we have two types. You can say here you can write it like this. Using routing protocols, the routers or firewalls will establish a neighborship between them and will establish a neighborship between them and exchange routing information dynamically, right? And exchange routing information dynamically. Okay. Here. So we have two types of, I told you this also, right? Dynamic routing protocols. First one, interior gateway protocol, IGP, and exterior gateway protocol, EGP. Okay. So if I talk about IGP, you can say IGPs are used within the organization, within the autonomous system number to exchange the routing information between the devices, right? So IGPs are used within the organization to exchange the routing information between devices or between network devices. Okay, clear. For example, you can write RIP routing information protocol OSPF and BGP, etc. Okay, sorry, EIGRP. We are talking about IGP, right? Etc. If I talk about EGP, then you can say EGP is used to create neighborship and exchange routes between two different organizations or ASFs. Okay, we use EGP in large networks like service provider. Like service provider. Okay, BGP is the only EGP available nowadays. Okay, clear. So this is BGP protocol. Sorry, this is EGP. Okay, so let's discuss about OSPF. So we will learn about OSPF protocol and BGP, these two protocols. Okay, so let's discuss about OSPF protocol. It is called Open Shortest Path First, OSPF. Okay, Open Shortest Path First. So if I talk about OSPF, OSPF is a linked state type of routing protocol. I told you about different types of IGPs, right? मैंने आपको IGP के type बताए थे. Distance Vector Routing Protocol, Hybrid Routing Protocol, and Link State Routing Protocol, right? So these are the three types. Now I explained how they are different from each other. Okay. So if I talk about OSPF, OSPF is a link state routing protocol. Okay. See, routing is not our concern, right? Here we will not discuss routing in depth, you can say. I will show you how can you configure it on the firewall. Because routing will be performed by the routers. If you want to perform path manipulation, route filtering, you will do all these things on the routers, right? On the next generation firewall, we are configuring routing just to make the reachability, okay? So if I talk about OSPF protocol, OSPF is an open standard protocol and it is a link state type. It is a link state type of IGP, right? Interior Gateway Protocol. Or you can say that it is a link state routing protocol. And it is an IGP, Interior Gateway Protocol. Okay, clear. It works at layer 3 in a OSI model at network layer, and its IP protocol number is 89. OSPF is 88, I think. Okay. its IP protocol number is no, it is correct 89. Okay, clear. Because it works at layer 3. So its IP protocol number is 89. Okay, to identify it as at layer 3. Okay, OSPF will dynamically discover the neighbor routers and establish neighborship with them to exchange routing information. Okay. OSPF will dynamically discover the neighbor and establish neighborship with them. Okay. To exchange the routing information. When OSPF routers or OSPF enabled routers become neighbor, when OSPF enabled routers become neighbor, they will exchange full updates for the first time, and after that they will exchange only the triggered update or partial update. It means whenever new route will be added or removed from OSPF database, then only an update will be sent. Okay, update message will be sent. It has, or you can say, its administrative distance is 110. Okay, AD value. In short, it is called AD. Okay. I think you guys are aware about these things, right? Okay. It has no hop count limit. It has no hop count limit. Okay. OSPF uses multicast IP address 224.0.0.5 for all routers and 224.0.0.6 with DR and BDR. Any idea about designated router and backup designated router? Here you can say for DR router. Designated router. Okay. Its hello timer is hello time is 10 seconds and hold down time is 40 seconds. Okay, clear. It supports route summarization and VLSM, variable length subnet mask. Okay, clear. It is a classless routing protocol. I'm just telling you some characteristics of OSPF. Okay, clear. Here you can say when we enable OSPF on a router interface or firewall interface, then that interface will start sending hello messages after every 10 seconds on multicast IP address 224.0.0.5. Okay, on multicast IP address 224.0.0.5 to perform dynamic neighbor discovery. Okay, dynamic neighbor discovery. Clear. The OSPF enabled routers will perform or will verify specific parameters. I will tell you about them, which are required to match to create neighborship. If parameters are matching, then routers will establish, right, the neighborship and they will be able to exchange the routing information between them. Okay, clear. This is how OSPF will discover the neighbor. So as soon as you will enable OSPF on a router interface, that router will start sending OSPF hello messages out of that interface. Okay, on multicast IP address 224.0.0.5. If on the other side router OSPF is enabled, then that router will also send its hello message, right? So both routers will exchange some parameters with the help of hello message to perform dynamic discovery and to negotiate the parameters this hello message is being used. Okay. Clear. Here you can say to establish the neighborship and to exchange the routing information. The OSPF routers will exchange some packets. Okay. First one is hello, like I told you. Okay. Then we have DBD. After that, we have LSR. Then LSU and then LSAT. DBD is called database description. Okay. LSR is called link state request and LSU is called link state update, and LSAC is called link state acknowledgement. Okay, link state acknowledgement. Okay, so these are OSPF packets which will be exchanged between the routers to create the neighborship. Okay, clear. Now you can consider it like this. For example, here we have a router connected and we have another router connected. This is R1 and this is R2. Okay. Behind R1, we are running some subnets, some networks, right? And behind R2, we are connecting some other LAN. Okay. Here you can say that behind R1 we have 10.1.1.0/24, 10.1.10.0/24, 10.1.11.0/24, 10.1.12.0/24. These networks are connected, right? And behind R2 also some networks are running. Okay. यार ये ज्यादा साइड में हो गया तो 1 minute. Okay, now it's not good. Now it's good. So here we are running, as I was telling you, 10.1.1.0/24, 10.1.10.0/24, 10.1.11.0/24, 10.1.12.0/24. Behind this router 2, we are running networks 10.1.20/24, 20.0, 21, and 22. These are networks running behind this. And between R1 and R2, we are running 10.1.12.0. Okay. Now, if we want to exchange this routing information, we want that these routes which are directly connected with R1 and these routes which are directly connected with R2, they should be exchanged between the devices, right? R2 should be able to reach these R1 networks and R1 should be able to reach this R2 network, right? We want this. So you can configure a static route first of all. But if you have a large network where hundreds of routers are connected, thousands of devices are connected, right? Then you will have multiple networks, multiple subnets. You will not be able to configure them using static routes. Okay. So what you need to do here, you can run a routing protocol. Okay. OSPF. You can run a routing protocol, which is called OSPF, right? Now, I told you that in OSPF, there is no hop count limit, right? In OSPF, there is no hop count limit. So you will deploy OSPF with the help of area. Okay. You will deploy OSPF with the help of area. Now, what is area? Right. So area is a logical group. Here you can write it like this. OSPF. What is this? OSPF does not have hop count limit, but we deploy OSPF in areas so that we can simplify the design for OSPF network, OSPF topology, and for OSPF network and reduce the device resource utilization. Okay. Area is a group of or area is a logical group of routers within a single OSPF administration. So whenever you are going to configure OSPF, you will deploy it, you will configure it using area. Okay, using area. Right. Cisco recommends to put to configure, you can say maximum 50 routers within an area. After that, you can create new area, right? Okay. An area is identified using a 32-bit long ID which is defined in dotted decimal format like an IPv4 address. Okay, like an IPv4 address. Clear. The routes which are exchanged within the area are called intra area routes, and the routes are exchanged between the areas, between two different area, you can say, are called inter area routes. Okay, are called inter area routes. So intra area routes means routes are exchanged within the area, and intra area routes means the routes are exchanged between two or more areas. Maybe in the network you are configuring area 1, area 2, area 3, area 4, area 0. Okay, here you can say that area 0 is called backbone area, and any area other than 0 is called regular area. Okay, clear. Area 0 is called backbone area, and any area other than 0 is called regular area. All the regular areas must be connected through backbone area. Okay, through backbone area. Let's say if you have multiple area configured in your OSPF network, then let's say area 1 is there, area 2 is there, area 3 is there, right? And the area 0 is also there. So area 0 is called backbone area. So all the areas like area 1, 2, 3, they are regular areas, right? So if you want to exchange the routing information between these regular areas, like between area 1 and area 2, then you have to connect them through the backbone area. Okay. You have to connect them through the backbone area. Clear? So this is about area. So just remember, whenever you are going to configure OSPF, with OSPF configuration, you will define area like area 0. Area 0 is called backbone area. It is very, very important in OSPF. All the regular areas must be connected with area 0 or backbone area. Okay. Now I was telling you about these packets, right? So whenever OSPF enabled router will try to establish OSPF neighbor and exchange the routing information, it will exchange these packets. Okay. So let's say we have configured OSPF between R1 and R2. So R1 will send its OSPF hello message. This OSPF hello message will include specific parameters that are required to match between R1 and R2. Okay. That are required to match. Now there are certain neighborship requirements that needs to match between the routers, okay, so that they can become the neighbor. Like first of all, area ID must match, okay. So on this interface, you are going to enable OSPF on R1, and on this interface also, you are going to enable OSPF on R2, so that they can become neighbor. Now you will configure same area ID on both of the devices, okay. Then only they will be able to become neighbor. So between two adjacent devices, if you are creating neighborship, then area ID must match. Apart from this, timers must match. Okay, let me write them. Neighborship requirement. First of all, area ID must match. Okay, area ID must match. Then timer must match. Hello and hold down timers must match on both of the routers. Then authentication must match. If it is configured, then authentication must match. Network ID and subnet mask must match. Okay. Must match. Then MTU size must match. After that, router ID must be unique. Router ID must be unique. Then stub flag must match. Okay. Stub flag must match. Clear. So these are the neighborship requirements. Okay. So in this first packet, R1 will send all of this information on multicast IP address 224.0.0.5. Now R2 is also configured with OSPF, so it will be able to listen for OSPF packets, right? And it will also send its hello packet. It will also send its hello packet, right? Okay. After exchanging these hello messages, if the parameters are matching, see these are hello messages, okay? If the parameters are matching, wait, what is happening here? Let me write it again. So after exchanging these hello messages, if the parameters are matching, then routers will move further. Okay. Or then The devices will move further. The sender initiator will send the next packet. Okay, DBD. Actually, the initiator will send empty DBD right now. Okay, just to synchronize the sequence number and to perform master slave election. Okay, these are empty DBD. Empty DBD means this DBD contains nothing, right? This DBD contains nothing. So this router R1 will send its empty DBD. Okay, just to synchronize the initial sequence number and to perform master slave election. Okay, in the response, or you can say the R2 router 2 will also send its empty DBD. Okay, empty database description message. After exchanging these empty DBD, both routers are aware. See, R1 has sent the empty DBD, R2 has sent the empty DBD, and they have elected who is the master, who is the slave, who will start the update exchange first, right? Now they will send their DBD messages, okay? Database description message. Now this database description message is responsible to inform the other and the router what are the routes stored in the sending router's database. That's why it is called database description. Okay. So this is DBD message, database description. Okay. In the response, okay, in the response, R2 will also send its database description message, which will give the description of R2 database, right? R2 R1 को बता देगा कि मेरे पास ये particular routes है. R1 R2 को बता देगा कि मेरे पास ये particular routes है, right? Now R1 knows that it does not have any route connected with R2 in its routing table, and R2 knows that it does not have any route connected with R1 in its routing table. So they will generate LSR, link state request. They will generate LSR, link state request. Okay. They will send LSR link state request so that they can ask for the routes which are not installed in their OSPF database. Okay. So here you can say these are LSR packets, link state request. Here in this link state request message, the router will include the LSA. See here you can write one line in OSPF. In OSPF, the routes or the routing information is exchanged in the form of LSA, link state advertisement. Or you can write it like this, link state advertisement, LSA. Okay. To exchange the routing information in OSPF, the routers will exchange different types of LSAs, link state request. Okay. Different types of LSAs. Okay. Clear. So in this database description, R1 will tell whatever LSAs are stored in R1 database. Okay. It will tell to R2, and R2 will send its database description message. So R2 will tell what are the different routes or networks stored in its routing table, right? This is how database description message is exchanged. And after getting the database description message, both of the routers will check their local OSPF database with the received database description message. Whatever routes are not available in their local routing database, for them, they are going to generate this LSR, right? So R1 will send LSR to R2, R2 will send LSR to R1, link state request. Then these routers will exchange link state update packet. And this link state update packet contains link state advertisement, LSAs. Okay, it contains LSAs. Okay, so this packet is LSU, link state update packet. It contains all the LSAs which will be exchanged between the routers. Okay, and after exchanging these LSAs with the help of LSU packet, these routers will exchange LSAC acknowledgement just to inform each other that the neighborship negotiation is completely done. Routes are also exchanged. So this is just acknowledgement, LSAC. Okay. Clear. These are the OSPF packets which will be exchanged between the routers to create the neighborship. Okay. Clear. Now there are many other things in OSPF. Like when we configure OSPF, a role is assigned to the router. Okay. In OSPF, we have different types of routers, you can see. Okay, different types of routers. First of all, we have backbone router. After that, we have internal router. Then we have area border router. Then we have autonomous system boundary router, ASBR, ABR. Okay, it is like this. So backbone router is the router which has all of its interfaces assigned in area 0. Okay, the router which has all of the interfaces connected in area 0 is called backbone router. Backbone router. Okay. Internal router, the router which has all of the interfaces configured or connected in a regular area is called internal router. Okay. After that, area border router. Okay. Area border router. The router which has a link connected with area 0 and a regular area is called area border router. It is used to exchange only the routing information between the between different areas. Okay, clear. This is called area border router. Okay. If I talk about ASBR, you can say that In OSPF, the router on which we perform route redistribution is called ASBR. Autonomous System Boundary Router is called ASBR. It is used to propagate external routes in OSPF domain. Okay. It is used to propagate external routes in OSPF domain. Okay. So you can configure this Palo Alto firewall for route redistribution also in OSPF, right? It will become ASPR, right? So these are the different types of routers that can be configured on Palo Alto firewall. Okay. Clear. After this, in OSPF, you have OSPF states, you have OSPF network types, right? So you can learn about them. For now, let's go to the lab and try to perform the practical for OSPF protocol. Let me start these routers and this switch. See, this R2 server is also a router, right? So for now, I can use it as a router to configure OSPF. Okay. So I'm going to configure OSPF area 0 between R1 and Palo Alto firewall here, and area 1 between Palo Alto firewall and this R2 server. Okay. Because this is a router in the end, so we will be able to run routing protocol. Okay. So let's go to the Palo Alto firewall CLI. You can see it is started. You can log in. Right. You can check its management related configuration, show interface management. Here you will find IP address, subnet mask, gateway, right? So you will also be able to check interface configuration if you want, and other configuration from the CLI using the show commands. We will see them. Okay. But for now, let's take the GUI access. So go to this management PC and open the browser. R1 and R2, they are also started. R1 and this is R2. On the switch, we don't need to do anything, right? They are also configured. Now let's go to Palo Alto firewall and go to the management PC to take the GUI access, right? The IP address is 150.1.7.50. Okay. And here we can log in to get the GUI access of the firewall. Okay, guys. So we will configure OSPF area 0 between R1 and Palo Alto firewall, and OSPF area 1 between Palo Alto firewall and R2 server. Okay. This is your router 2, which is connected with the internet. So between this Palo Alto firewall and this router 2 connected in outside, we will configure BGP later, not now. Okay. So for now, let's configure OSPF on E1 by 2 and E1 by 3 interface, right? Okay. So here we are able to log in, right? Close this, remind me later. After this, we need to go to network tab because we want to configure routing. So go to network tab. Here our interfaces are already configured, right? We did this configuration in the last class. And zone is already defined. Zones are configured, right? Now you can go to virtual router because we are using the interface mode layer 3, right? So here you can see in virtual router, we configured these two static routes. Okay, so go to the virtual router, go to static route. Now I will delete this static route 10.1.11.0 because, okay, I need to delete this, not clone. Because this time this network will be received by OSPF on the Palo Alto firewall, right? Dynamically. Okay, it is gone. So here we have only one static route. Now we need to configure OSPF. So we will go to my VR virtual router and here you can configure RIP, OSPF, OSPv3, BGP, multicast routing, these things, right? So go to RIP, sorry, go to OSPF and enable it. Okay. Here it is saying reject default route. So if you are redistributing default route in OSPF, then it will be rejected. But I will uncheck this because we don't want to reject the default route. Okay. Then router ID for this device. This router ID must be unique on every OSPF enabled device. Okay. So for this firewall, I am taking router ID 10.10.10.10. Okay. This can be any IP address. See, the firewall will be able to elect the router ID automatically also, but here it is an option to define it. Okay. After this, you need to configure area. So let's click on add. Here you will define for area 0, it will be 0.0.0, area 0. After that in OSPF for LSA filtering, you can configure stub or NSSA, it's up to you. But we are taking normal area right now, right? We are not configuring stub area or NSSA area, just a normal area. And range command is used when we want to do summarization. Okay. Interface. Using interface command, you will configure interface in this area. Virtual link is used to create a virtual link between the regular area so that they can connect with the backbone area. But we are not configuring it. So just define the interface on which you want to enable OSPF. Okay. So click on add. Here select interface E1 by 2. It is enabled, OSPF is enabled, right? You can make it passive. Hello interval, dead counts, you can change these optional values. You can define authentication profile. अगर आप authentication profile define करना चाहते हो, just to authenticate your OSPF neighborship, then you can create and you can call it here. Okay, मैं कर दूंगा. For now, just click OK. So E1 by 2 is added. Let's add E1 by 3 also. But E1 by 3 is in area 1, right? देखो ये E1 by 2 एरिया 0 में है तो ऐड कर दिया बट E1 by 3 is not in area 0, it is in area 1. So just click on OK for now and add a new area. Area 1 can be defined like this 000.1. It is a normal area. Then for range, you don't need to define anything right now. Go to interface and call E1 by 3 interface, right? E1 by 3. Here also you can define authentication profile if you want. Okay. You can click on this drop down. You can click on auth profile. This is OSPF authentication. You can use simple password, clear text password, or you can use MD5 authentication, right? So I am selecting MD5, then click on add. Key ID, key identifier is 1, and this is my key, PA12345. PA12345. Now, whenever any router will come to this Palo Alto firewall E1 by 3 interface to create OSPF neighbor, the Palo Alto firewall will verify this key. If this key is correct, correctly configured on the router, on the front end router, then OSPF neighborship will be established. Otherwise, it will be failed. I have created the key and I have applied it here. Okay. Now authentication profile is called, right? Click on OK. For area 1, this interface is defined. For area 0 also, let's call that profile. Okay. Go to interface, edit this. and call this authentication profile, OSPF authentication. Click on OK. So two interfaces are advertised, right? Here you can create auth profile. I created this on the fly, right? But you can create it here. Export rules are used to redistribute default route or any other routing protocol in OSPF. Okay, because in the network you can use different routing protocol like RIP, EIGRP, OSPF, and static routes also. And if you want that different routing protocols should be exchanged, different routing protocols routes should be exchanged between the devices, then you need to configure route redistribution. Okay, so we'll do it later. Just for now, go to advanced options. Here you can see some advanced option. If you want, you can change. Otherwise, leave them. Okay. तो देखो OSPF में कितनी कम settings हैं यहाँ पे, right? We have very less number of settings in routing because the firewall is not a routing device. It is a next generation firewall. It will perform most of the security features, right? Not routing or something. So here you have very limited features. Okay. OSPF is configured. Just click on OK. Okay, yes. And click on commit so that the changes can be applied. Commit. Now you need to go to R1 and this R2 server and you need to configure OSPF. So let's go to R1 CLI. Here you will run a command router OSPF1. Here I am defining router ID 1.1.1. Okay. And let's advertise the network 10.1.1.0, then wildcard mask and area 0. We are on R1. Okay. So I have advertised this 10.1.1.0 network, this one. Then we have two more networks 10.1, 10.0, area 0. Then 10.1, 11.0, right? Area 0. So from R1, I have advertised these three networks, right? Apart from this, we configured OSPF authentication type MD5. So we need to go to interface E0 by 0 of this router and IP OSPF authentication message digest and IP OSPF message digest key 1. Okay. MD5 and the key is PA 1, 2, 3, 4, 5. This key is also configured for OSPF authentication, right? We defined this key on the firewall, right? As soon as the configuration will be applied, OSPF neighborship will be up. You can see with R1 OSPF process ID 1 neighbor 10.10.10. It is the router ID of Palo Alto firewall on interface E0 by 0 from loading to full. Loading done. It means OSPF neighborship is up between R1 and Palo Alto firewall. We have advertised these networks from R1 and then I configured OSPF authentication on interface E0 by 0, which is connected with Palo Alto firewall, right? And here we defined this key ID 1, which was configured on the Palo Alto firewall also. And this key PA12345. This is the password actually. If this password is wrong, right, then OSPF neighborship will not be established. Now let's configure this R2 server also. Here you can run router OSPF1. Okay, let's enable IP routing. हमने क्या किया था इस राउटर को एज अ होस्ट कॉन्फ़िगर किया था तो आईपी राउटिंग डिसेबल कर दी थी राइट बट नाउ आई एम कॉन्फ़िगरिंग ओएसपीएफ ऑन दिस राउटर सो आई एम एनेबलिंग आईपी routing. Okay, now I can run router ID. You can say 2.2.2 network 10.1.2.0 and wildcard mask area 1, right? And after that, here I will create a loopback interface for 10.1.20.0 area 1. Interface loopback 1. Just to show some connected network behind this router, I am creating this loopback interface. Okay. Now it is correct. Yeah. Do show run section router. They are the part of area 1. So on R2, you will find, okay, on R2 server, yeah, on this router only, you will find that OSPF neighborship should be up, right? but it is not showing up. Go to the firewall. Here you can check OSPF neighborship from the CLI. Show routing protocol OSPF neighbor. I will show you on the GUI also how can you monitor your routing process. Okay. So on the firewall right now it is showing only one neighbor, which is R1, and it is in area 0. Okay. It is the part of area 0. But R2 server is not able to create the neighborship. Why it is so? Do show IP OSPF interface brief. On the Palo Alto firewall also we configured OSPF, right? For the interface E1 by 3. Let me check. I think I have not configured authentication on R2, right? मैंने R2 सर्वर पे ऑथेंटिकेशन कॉन्फ़िगर नहीं किया, इसलिए ये नेबरशिप अब नहीं आ रही है. Because R2 is not sending any password. R2 server is not sending any password to Palo Alto firewall. And Palo Alto firewall is configured to authenticate the OSPF enabled router, right? तो यहाँ पे क्या करना है आपको? IP OSPF authentication message digest, then IP OSPF message digest key 1 and algorithm MD5 key is PA12345. अब देखो जैसे ही मैं की एंटर करूंगा अभी नेबरशिप अप आ जाएगी. जस्ट वेट फॉर 1 minute. R2 server will be able to create the neighborship with Palo Alto firewall. Right, it is up. You show IP OSPF neighbor. अब देखो आप अगर Palo Alto firewall पे जाओगे वहां पे एक बार नेबरशिप वेरीफाई करो CLI से. This is the command. Show routing protocol OSPF neighbor. It will show you two OSPF neighbor. Okay. First one, this is your virtual router, my VR, and this is neighbor address 10.1.1.1. It is R1. Here you can see neighbor router ID 1.1.1. It is R1 router ID, right? Area ID 000. Here you can see this is virtual router, my VR. This is neighbor address 10.1.2.1. This is for R2. Area ID, here you will find 000.1. This is neighbor router ID 2.2.2. Neighborship status full. It means neighborship is established, right? You can check show routing protocol, show routing route, enter. Now it will show you OSPF routes also, जो OSPF से receive हुए, जैसे ये 10.1.1.0, ये OSPF से आ रहा है, OSPF inter area route, OIA means OSPF inter area route. ओके, यहाँ पे आपको मिल जाएगा, देखो. Okay, this one, and after that here you will see this one 10.1.2.0 route. It is also SPF route. Right, 10.1.10.0, 11.0, ये सब क्या है? OSPF routes है, देखो यहाँ पे. Okay. Now on R1 also you can check. You will be able to get the routes from R2. Do show IP route. See, R2 routes are coming here. Okay, we are on R2, so no problem. R1 routes are coming here, right? आप R2 पे चले जाओ, सॉरी R1 पे चले जाओ और यहाँ से चेक कर लो. डू शो IP route. Here it will show you all the R2 server routes 10.1.2.0, 10.1.20.1, right? Are you getting this? Any doubt, guys? Okay. तो OSPF आप कॉन्फ़िगर कर लोगे? बताओ.